The second required attribute is instance type. And this is, as you know, basically just the type of the server defined right here. So based on how much resources you want, you can choose one of the types. If you want the free tier eligible one, let's go with T2 micro. And instead of hard coding the type here, maybe you want to deploy different types in different environments. We can also make this configurable and actually reference it as a variable. So let's create instance type variable. Let's define it up here. And let's assign its value right away and set it to T2 micro. It's this value right here. So we have the 2 required attributes set. Now the rest are optional. However, we want to set some of the configuration so that our EC2 instance actually ends up in the subnet that we created in the VPC and gets the security group that we defined right here. Now, as I said, these attributes or the rest of the attributes are optional, like subnet ID and security group ID, etc. And it means that if we do not specify them explicitly, then the EC2 instance that we define here will actually be launched in a default VPC in one of the AZs in that region in one of the subnets. However, we have created our own VPC and we want this EC2 to end up in our VPC in the subnet that we created and be assigned the security group that we created in our VPC, right? So because we don't want the instance to be launched in the default VPC, but rather in ours, we have to specify all these values, right? So optional just means that the default components will be used. However, we want to override that. So let's specify some of these values. First, we have the subnet ID. And we want our EC2 to end up in our subnet. Again, if we had multiple of them, we could choose whichever we want. We just have one, so that's easy to choose from. And that's our subnet ID. As a next one, we have VPC security group IDs. And this is actually a list because we can assign and configure multiple security groups for our EC2 instance, not just one. We just have one, so I'm gonna reference that. It's AWS default security group. Default is G. And I almost forgot, we need to use the ID and not the whole object. Otherwise, Terraform will give us a warning when we execute Terraform plan. So we have the subnet ID and we have the security group ID. And now we can set the availability zone. And you remember that we have actually configured the availability zone as a variable, and we used it in subnet as well. So we can just grab that variable and use it here as well. And this will basically tell Terraform to spin up the server in the subnet and assign it the security group we defined for it. And since the subnet is also in this specific AZ, this will basically do the same. Another attribute to set is associate public IP address, because we want to be able to access this from browser and as well as SSH into it. So we need a public IP address of the server. So associate public IP address will be true. And one final thing, again, for SSHing into the server is the keys. And if I go back to the EC2 let's actually leave this wizard. We don't want this anymore. Let's go to EC2. And in this overview, you see key pairs. And these are basically, this is empty right now, but these are the key pairs that allow you to SSH into the server by creating public private key pair or SSH key pair. So we can actually create a key pair manually in the UI here. Let's call it server key pair. And let's choose PEM format as a file format. This is the one that you're gonna need if you're working with Windows. But I believe PEM file also works for Windows. So let's create the one with PEM file. And as soon as we create it, the PEM file gets downloaded. So basically what happens is that AWS created a private public key pair, and we have the private key part in this file. So we have to keep this file securely because this basically holds the information that we need to connect or access the server, right? So if you give it to someone else who shouldn't have access to SSH, they will actually be able to access the server. So you have to keep it in a secure place, and you need to restrict the access and permissions on that file. So a best practice for keeping this PEM file, actually, this private key, is to move it from the downloads folder to your ssh.ssh folder inside your user folder. So we can do that in the terminal actually. So we can move, and I know that it's in the downloads folder. So wherever it got downloaded, basically you find it, and this is the PEM file, and we're gonna move it into SSH folder. And there you go. So we have it, and this is basically a secure place on your internet to store private keys, basically anything that should be restricted and not easily accessible for other users. And another thing we should do on it is restrict the permission. So right now, you see that it has read permission and write permission as well. What we need to do is set its permission to be stricter, and we're gonna set it to 400. And let's execute. Let's do it again, and there you go. We just left the read permission for the owner, which is my user, and it is inaccessible for everybody else. And note that this step here is actually not optional. It is required because whenever you use a PEM file that doesn't have this strict access, AWS will actually reject the SSH request to the server. So you will have to modify the permission of the PEM file. It is a required step. So basically, we just created a key pair in AWS. It got downloaded locally, and we have saved it into a secure location in .ssh, and we have restricted its permission so that our user has a read-only access to it, so that we can use it for connecting and SSHing into EC2 server. Great, so that step is done. And now we can use that key reference right here, right? Because we have the key, however, we have to associate that key with the server, right? And we're gonna do that using key name. And the key name is basically the reference to this name right here, right? So we're telling AWS, associate the key called server key pair with this specific instance. So we're gonna hard code it, and there you go. So, and this association will basically make it possible for us to use that PEM file to SSH into our instance. Great, and The only thing missing is the tag for name. Let's copy it from here. And let's call it dev server. And now it's time to execute our configuration and create the EC2 instance with all of these attributes set. So first let's do Terraform plan. And again, Terraform plan basically tells us where we have an issue. It seems like on 105. I forgot to put equal sign here. So let's try again. And these are a bunch of attributes for our instance that we're creating. Right now, most of them are not set, obviously, because they will be generated by AWS, like public and private IP addresses, host ID, and a bunch of other stuff. But it looks good, so we can do Terraform apply and create the EC2 instance. And it will take some time because the server will be initializing. Let's actually go to dashboard and refresh. And we have a running server which is still initializing. And let's see. The creation is complete. However, it's still initializing. So let's actually wait for that. And if I click inside, we're going to already see a bunch of values that have been generated. So in the summary, you see the IP addresses like private IP address and public IP address. And as you see here, the private IP address for EC2 instance is from the range of subnet CIDR block, right? So our subnet has CIDR block defined at 10.0.10.0. And every EC2 server, every instance inside the subnet will get IP address from that range. And as you see, our EC2 instance has, or one of the IP addresses taken from that range. So this is how it works. And then we also have the public IP address because we defined the attribute to assign public IP address to the instance. And this will basically allow us to SSH into the instance as well as access it from the browser. So let's refresh again. And there you go. Status check is green. It is fully initialized. So now we can actually just SSH into it using our PEM file. So I'm going to do SSH, and then we have to specify the PEM file using this flag. This is the PEM file that got downloaded, and then we have the user, which is the default user of EC2 instances on these Amazon Linux images, and then we have the public IP address, which we can grab from here. And this is the endpoint. This is the key, the private key we associated with that instance. And if I execute it, we'll have to approve. And there you go. And again, this is the private IP address because we're inside the server right now, which is defined here. So the EC2 instance got created, it got initialized, and we were able to SSH into it because we have defined the key name association right here.